Hello friends, I am Samir and I welcome you all to your own YouTube channel Aryabhatta. Friends, today's our topic of discussion is some special type of matrices. So, here we are going to discuss some special categories of matrices that we left and we have not discussed it before. In that category, our first matrix is orthogonal matrix. Now, a square matrix with real elements is said to be an orthogonal matrix if its transpose is equals to its inverse matrix. If the inverse matrix, if A is a square matrix and if A inverse is equals to A transpose, then we used to say it an orthogonal matrix. So, very simple definition it is. Now, few examples I have written for you, collected for you. This is the second order square matrix with elements cos x, sin x, minus sin x and cos x row-wise. And this is a third order matrix which is of orthogonal matrix category. You can check yourself that if you will find out the transpose of these two matrices and you will find out the inverse of these two matrices, they will become equal. Okay, friends. Now, come to the properties of orthogonal matrix. A square matrix of order n is said to be orthogonal if A into A transpose, that means the product of A with its own transpose in any order. You can keep A into A transpose or A transpose into A is equals to the identity matrix of the same order n. That means, it is also a property and this one also you can use as the definition of orthogonal matrix. That means, a orthogonal matrix is a matrix where you multiply that matrix with its own transpose and you get the result as the identity matrix of the same order. That type of matrix is also called orthogonal matrix. Second property says that if A is orthogonal matrix, then its transpose is also orthogonal by nature. Third property says if A and B are two orthogonal matrices of same order, then both product of AB and BA are also orthogonal. That means, product of two orthogonal matrices of same order is also orthogonal matrix. Fourth property says if A is an orthogonal matrix, then the inverse matrix A inverse is also an orthogonal matrix. So, the inverse of an orthogonal matrix is also orthogonal. The fifth property says if every identity matrix is orthogonal by nature, every identity matrix is orthogonal. Now, the determinant value of orthogonal matrix is either plus 1 or minus 1. It is confirmed. Okay, friends. Now, come to the second type of special matrix, that is idempotent matrix. There is a law called idempotent law. This says that if we are multiplying A with A and we are getting the result the same as A, that means A square is equals to A, then that law is called idempotent law. So, if a matrix, a square matrix also satisfy that idempotent law, that means, if we multiply the matrix A with itself, A into A, that is shortly we are writing A square is equals to again the same matrix A, then we say that matrix as idempotent matrix because it satisfies the idempotent law. So, two examples friends for you, one second order matrix or one third order matrix for you, and you can check yourself, you can verify yourself that if you multiply these matrices with themselves, you will get that the result is again the same matrix. So, these two are good examples of idempotent matrix. Now, some properties of idempotent matrix. If A and B are two idempotent matrices, then product of A B is also idempotent if their product is commutative. That means, if A into B is equals to B into A, then A into B is idempotent. Then the sum of two idempotent matrices, that means A plus B is also idempotent if their product is commutative and that is equals to the 0 matrix, and this is if and only if. That means, it is vice versa process. That means, if A plus B is an idempotent matrix, then their product will result 0, and if their product results 0, then their addition is idempotent matrix. The third point says that if A into B, product of A B is equals to A, and if product of B into A, product of B and A is equals to B, then definitely A square is equal to A and B square is equal to B. This is the result we will get out of these two conditions. If these two are satisfied, we will get these two results. Now, the second property says that if A is an idempotent matrix and we are adding A with another matrix B, that means A plus B is equals to the same order identity matrix, then what about this new matrix B? Then B is also an idempotent matrix and their product is commutative, that means A B is equals to B A and both are equals to 0 matrix. So, this is all in idempotent matrix. Now, friends, our third special matrix is involutory matrix. Now, what is involutory matrix? A square matrix A is said to be involutory if A into A, the product of the matrix A with itself, is equals to the same order identity matrix. That means, if A square is equal to I, then we say that A is that involutory matrix. I have collected few examples for you. You can see these examples, second order, third order and third order, different 3 examples, and you can verify yourself. You multiply these matrices with themselves and you will see you are getting identity matrix of the same order as a result. So, these 3 matrices are examples of involutory matrices. Now, friends, come to the fourth category of special matrix, that is Nil Potted Matrix. A square matrix A is said to be Nil Potted matrix if there exists a positive integer m such that A to the power m is equals to O. O means 0 matrix. This says that, say we have a square matrix and if we are multiplying that matrix with itself again and again up to m times. Now, after multiplying the matrix A with itself up to m times, if we are getting the 0 matrix as a result, then that particular matrix which results in 0 after multiplying with itself up to m times is said to be Nil Potted matrix. It is not that every matrix is nilpotent, these are special type of matrices which used to result in 0 matrix after multiplication of itself with up to m times, and what is m? Positive integer. Now, if m is the least positive integer, that is the smallest of its kind, then we say that m is called the index of the Nil Potted matrix A. Say you are taking a matrix A and you are multiplying with itself again and again, and after multiplying 5 times with itself, you are getting the 0 matrix as a result. First time you obtained the 0 matrix after multiplying 5 times. So, 5 is that least positive integer. So, 5 is called the index of that particular matrix A. So, after that also if you multiply more matrices, we will again get 0 matrices afterwards, because once it becomes 0 matrix, then you multiply more A matrices with itself, the result will be always 0. So, that minimum number, that minimum positive integer m, or that 5 I have taken as example, is called the index of that particular matrix, Idempotent matrix A. So, friends, here are 3 examples I collected for you. You see the first third order matrix. This matrix, it is a Nil Potted matrix, its order is 3 and its index is also 3. That means, it is 3 rows, it has 3 rows and 3 columns. So, its order is 3 by 3, shortly I am saying 3, and if you multiply this matrix with itself up to 3 times, then you will get the 0 matrix as a result. So, order is 3 and also index is 3. Now, this second order matrix, it is a nilpotent matrix of index 2. It has order 2 and it has also index 2. That means, you multiply this one with itself up to 2 times, you will get the result as a 0 matrix. Now, the third example you can see here, it is also a nilpotent. It is of order 3 because it has 3 rows and 3 columns, but it has index 2. That means, you multiply this matrix with itself and only to multiply with itself 2 times only, and you will get 0 matrix as the result. So, order of the matrix and index of matrix, they are two different things for an nilpotent matrix. You can observe it through these examples. So, friends, I am sure that you are a little bit clear about this topic, special type of matrices. I tried to cover this today. So, thank you very much for watching this video. Thank you.